Hello students, welcome to MK Academic Solutions. So in this video we are going to discuss about the theories which explains the rate of reaction. Okay, right. So in the last video we have learned about the rate of reaction. What is the rate of reaction? Different type of reactions based on the rate or speed, and how to express the average rate and instantaneous rate, and how to relate the rate of formation, rate of decomposition with the rate of reaction, and one model problem also I have explained there. Okay. So now in this video I am going to explain to you theories which explains the rate of reaction. Okay. So there are mainly two theories are there which explains the rate of reaction. So the first one is collision theory. Collision theory, or it is also known as Arrhenius theory. Arrhenius theory, collision theory or Arrhenius theory. And the second one is transition state theory. Transition state theory or activated complex theory. Transition state theory or activated complex theory. Okay, right. So the first we will discuss about the collision theory. So what are the main important points in the collision theory? So the first one we are going to discuss, that is collision theory. Okay. So what is collision theory? So collision theory, according to collision theory, any reaction takes place due to collision of reactant molecules. Collision means colliding. Colliding means hitting with one another. That is known as what? Collision. Okay. Collision theory says that any chemical reaction. So any chemical reaction takes place due to collisions of reactant molecules, Okay. So these collisions are very high in case of binary molecules. Binary molecules means two molecules are involving in a chemical reaction. So these collisions are very high in bimolecular reactions. Bimolecular reactions means only two molecules are involving in a chemical reaction. Okay. So here what is the collision frequency here? 10 to the power of 22 to 10 to the power of 25 collisions per second. This is the collision rate. Okay. In a collision in bimolecular reactions. Okay. So here every collision is not give product. Every collision is not gives the product. Only few collisions only will give the product. Such type of collisions are called effective collisions. Okay. Here every collision not gives product. Only few collisions will give the product. Only few collisions gives product. Only few collisions gives product. Okay. So the collisions which give product actually known as what? Effective collisions. Okay. So the collision which gives product the collisions which give product are called effective collisions. Effective collisions indicated with F, small f. Okay, effective collisions. Okay, right children? So here next we see, if a collision to be effective, means if a collision want to be an effective collision, it must cross two barriers. If collision to be effective, it must cross two barriers. So what are the two barriers? They are energy barrier and orientation barrier. So two barriers, they are energy barrier and orientation barrier. So these two barriers it must cross if it want to give a product. So the first one is energy barrier. So energy barrier. So here what is the energy barrier? Okay, so here directly you understand by using the graph what is the energy barrier here. Okay, energy barrier. Okay, so here we are going to take the energy, kinetic energy. Here we are going to take here kinetic energy and here reaction coordinate. Kinetic energy and reaction coordinate here we are going to take. So here this is the, let us consider this is the average kinetic energy of the reacted molecule and this is the average kinetic energy of product. So before converting this reactant into convert into product, it must cross some energy. Okay, it must cross some energy. This is known as what? Energy barrier. Okay, so from here to here it is known as what? Activation energy. This is known as threshold energy. It is known as activation energy. Threshold energy and activation energy. So this is the average kinetic energy of reactant. Okay, so if a reactant want to give product, what it should do, children? It must cross this energy barrier, then only it will give the product. So not only to cross the energy barrier, but also one more barrier is there, that is orientation barrier. So a reactant molecule must cross the orientation barrier also, proper orientation also it should take. For example, here a reaction between A2 plus B2 is gives rise to 2AB. So let us consider this is the reaction. So in this reaction, A2 is the reactant, B2 is the reactant, and 2AB is the product. Okay. So here they must orient properly. They must orient properly. Then only they will give product. Okay. So let us consider like this. Okay. Okay. Right. Okay, right. Okay, let us assume. So now let us take this is the A molecule, and this is the B molecule, and B. So this is will be, let us consider this will be the proper orientation, and this is known as what? Proper orientation. This is the proper orientation. When the molecules, when the reactant molecules here, when they collide like this only, they are going to give the product. Okay, this is the proper orientation. We can indicate it with the P. Proper orientation. Here P is called orientation factor. Okay, orientation factor. What is P here, children? Orientation factor. Say if they collide like this, let us assume they collide like this. Okay, so let us assume they collide like this. Okay, so if they collide like this, okay, here A, this is A, and this is B, and this is the B. So now they are colliding like this. So this is the improper orientation. Okay, this is improper orientation. So when they collide with improper orientation, they will not at all give any product. Okay, so these are the two barriers a molecule must cross to give an effective collision. So what are the two barriers? The first one is energy barrier, the second one is what? Orientation barrier. So this is the orientation barrier, second one orientation. Okay, so this is the orientation barrier. Okay, let's do magic. Okay, come. So orientation barrier, second one is the orientation barrier. Okay, these are the two barriers a molecule must cross to give product, to give what? Product. Okay, right. So here what we discussed, children, in the collision theory. Once let us revise the points what we have discussed in the collision theory. So the first collision theory tells that any chemical reaction takes place due to collision of molecules, due to collision of what? Reactant molecules. So these collisions are very high in case of bimolecular reactions, that is 10 to the power of 22, 10 to the power of 25 collisions per second. So this is also known as what? Collision frequency Z. Okay, this is indicated with the collision frequency Z. So here every collision is not give the product, only few collisions will give the product. The collisions which give the product are known as what? Effective collisions. So if a collision want to be effective, means if a collision to be effective, if the collision want to be an effective, it must cross the two barriers. What are the two barriers? They are the energy barrier and orientation barrier. So here what is the energy barrier? So here every molecule is having somewhat energy, that is known as what? Kinetic energy. So this reactant molecule want to convert into product, it must cross this much of energy. This is known as what? Energy barrier. Okay, here this is known as what? Threshold energy. This much is known as what? Activation energy. Okay, so when the molecule cross this energy only, it will give some effective collisions. So it is not only cross the energy barrier, but also it should cross the orientation barrier. So means proper direction only they should collide with each other, then only they will give the product. If even though they are crossing the energy barrier, but they are not crossing the orientation barrier, improper orientation, they are coming and they are colliding with each other, means simply they will bounce back without giving any product. Okay, so these are the two conditions a colliding molecule or a reactant molecule must cross and it will give the product. Okay, right. So now let us summarize this collision theory. Okay, so here we know rate of reaction is directly proportional to concentration to the power n, and here rate of reaction is equal to K into concentration to the power n. Okay, concentration to the power n. So if we consider concentration to the power n is equal to constant, here rate is equal to, so rate is proportional to, okay, rate is proportional to K, means K increases, rate is also increases. So here what is K? Here K is known as what? Rate constant. K is called here what, children? Rate constant. And according to Arrhenius theory relation, we know F is directly proportional to rate of reaction. Okay, and here F is directly proportional to e to the power of minus EA by RT. So this is known as what? Boltzmann relation. Okay, now you consider this as the 1 and this as the 2. Okay, so now you compare the 1 and 2, 1 2, okay, or else just make it as the 2 and you make it as the 3. Okay, now compare the equations 1, 2 and 3. So from equations 1 and 2 and 3, what we can write, children? F is directly proportional to K, or simply you can take K is directly proportional to F. K is directly proportional to F. So here instead of F, what we can write? E to the power of minus EA by RT. E to the power of minus EA by RT, or else simply K is equal to A into E to the power of minus EA by RT. So this is known as what? Arrhenius relation. This is known as Arrhenius relation. So now let us see the modified form of Arrhenius equation. Modified form of Arrhenius equation. Modified form of Arrhenius equation. Okay, so how we are going to take the modified form of Arrhenius equation? So simply we are going to apply the logs. Okay, in this Arrhenius equation, what we are going to do, children? we are going to apply the logs. Okay, apply the log or simply natural logarithm you apply. So ln k is equal to ln a plus minus ea by rt. Okay, we can write like that, or else simply ln k is equal to ln a minus ea by rt, or else you, in case of with log you take, in case of natural logarithm you take the log base 10. So when you remove the ln, so when you are replacing with log base 10, we should multiply with 2.303 log k, that is equal to 2.303 log a minus ea by rt. So the total equation you divide with the 2.303. So what you will get, log k is equal to log a minus ea by 2.303 rt. So this is the modified form of Arrhenius equation. Okay. So now this, by using this equation in exam they will ask graphs also. Okay, they will give the graphs, what are the terms also they will ask in the graph. Okay. So now let us draw the graph for this Arrhenius equation. Okay. So now first let us take the Arrhenius equation. Simple form of Arrhenius equation is what? K is equal to a into e to the power of minus ea by rt. Okay. So or ln k is equal to ln a minus ea by rt. So now we are going to plot the graph. We are going to plot the graph between temperature versus ln k, temperature versus ln k. Okay. So now let us plot that graph, temperature versus k. Okay. Okay, right. So on this y axis I am going to take the ln k, on this x axis I am going to take 1 by t, 1 by t. Okay. So now let us split this, like this we can write as ln k is equal to minus ea by r into 1 by t plus ln a, like that we can write. So now in this form you can understand it is just like y is equal to minus mx plus c. In this form you just can understand as y is equal to minus mx plus c. So here y is ln k, x is what 1 by t we have taken, and c is the intercept on y axis, c is the intercept on y axis. So here this is the ln a, and here what, which slope here you are getting? Negative slope. Okay, negative slope, the downward curve you will get. Okay, this is the negative slope. So here what is the slope is equal to, here slope, okay, here slope equal to, slope is equal to minus ea by r. Okay, or else you can draw this same graph for another equation, that is, okay, first let us take the graph. Okay, right. Okay, so this equation we can write as log k is equal to log a minus ea by 2.303 RT. So this equation again we can write as log K is equal to minus EA by 2.303 into 1 by T plus log A. Okay, so here I am going to take the graph between the log K and log A. So now this is also y is equal to minus mx plus c. Okay, so here what is the c intercept on the y axis. Okay, so what is the intercept here? Log A. Log A is the intercept on the y axis, and here slope is negative slope here will get, so like that curve, downward curve you will get. So here slope is equal to, so here slope equal to minus EA by 2.303 R. Okay, this is the Arrhenius theory and Arrhenius explanation how a chemical reaction is going to be takes place. Okay, next we will see the transition state theory. Okay, next we are going to see the transition state theory. So before discussing the transition state theory, what are the limitations of this Arrhenius theory or collision theory? So what are the limitations of Arrhenius theory? Limitations. Okay, so what are the limitations of Arrhenius theory? The first one is it is applicable for simple gaseous molecules or binary molecules. It is applicable for only simple gas molecules, simple gas or binary collisions, not applicable for the complex reactions. Okay, not applicable for complex reactions. Collision theory will not consider bond breaking and bond making. Collision theory, what it is going to do? It is not at all going to consider bond breaking and bond making in reactant and product molecules. It will not consider bond energy change in bond breaking and bond making. Bond breaking and bond making in products and reactants and products. In reactants and products. Okay, next it will not consider enthalpies of reactants and products. So it is not considered, enthalpies of reactant and product. Reactants and products. Okay, and according to this theory, the decomposition of HI and N2O5 is same. According to this theory, according to this theory, decomposition of HI hydrogen iodide and N2O5 both are same. both are same, both are same at same condition, at similar conditions, at similar conditions, but they are different, but they are different. Okay, so these are the limitations of which theory? Collision theory. Okay, next we are having what, which theory? Transition state theory. Okay, next we will see the transition state theory. So what is the transition state theory? We will discuss. Okay, so transition state theory, transition state theory. So what is the transition state theory? This also explain how the chemical reaction is going to be takes place. Okay, according to this transition state theory also, according to this theory also chemical reaction takes place. Chemical reaction takes place due to collisions, collisions only. And here what it make difference from the collision theory means, see here, when the reactant molecule collide together, they are going to produce a short, very highly energy compound molecular cluster, that is known as what? Transition state. See, for example, here A2 plus B2 are reacting together to produce 2AB. So before producing this product, what is going to happen here? So here a bond is present between the A and A. Okay, so A, this is the bond, and B and B, this is the bond is present in between B and B. Okay, so here when they are going to collide with each other, the original bond present between the A and A is going to be break, the original bond present between the B and B also going to be break, and there is a new bond formed between A and B, and here also a new bond formed between the A and B. So now how we are going to show that? Okay, so this is the AB. So now let us take okay, so these are the old bonds are going to break, and new bonds. Okay, so these are the new bonds are going to be formed. So here this is the bond breaking, and this is also what? Bond breaking. Okay, next what is this one? This is the bond making, and this is also bond making. Okay, so here what we observe simultaneously, children, here we observe these are the old bonds, these old bonds are going to be break, and these are the new bonds are going to be formed. So now it is a highly energetic molecular cluster. This highly energetic molecular cluster is known as what? Activated complex or transition state. Okay, so activated complex or transition state. Okay, so this highly activated complex or transition state is nothing but a highly energetic molecular cluster. So this is the transition state, simply we can indicate with the TS. So it is highly energetic molecular cluster, highly energetic molecular cluster. Okay. So what is the transition state or activated complex means highly energetic molecular cluster. So this transition state may be converted into product, or sometime it may be converted into reactant. Okay. So this may be converted into product like A, B. So this is the product, or sometime it again come back to the reactant. Okay. This is what a transition state theory. Okay. So now let us see the some important terms in this transition state theory. Okay. Okay, right. So this is the reaction coordinate, and this is the energy. On this y axis we are going to take energy, on the x axis we are going to take the reaction coordinate. So now let us consider, here we are having the reactants. This is known as what? Average kinetic energy of reactant, and this reactant is entering in a highly energetic state. This is known as a transition state or activated complex. Okay. This transition state may leads into the formation of products. Okay. So this is the product, and this is known as what? Kinetic energy of product, and this is known as kinetic energy of reactant, Ke of R. Okay. So now this is known as what? Threshold energy. Okay. This is the threshold energy. This is known as what? Threshold energy. So here what is the threshold energy? Threshold energy is nothing but the energy is required by a reactant molecule to cross the energy barrier. Okay. This is known as what? Threshold energy. So this is the threshold energy. Okay. What is the threshold energy? Means the minimum amount of energy required by a reactant molecule to convert into product is known as what? Threshold energy. Okay. So the minimum amount of energy, the minimum amount of energy required for reactant molecule to give product, that is known as what? Threshold energy. And this much is known as what? Activation energy. So here what is activation energy? Activation energy means the extra energy required by the reactant molecule to give product. Already this reactant is having this much energy, and how much extra energy required? This is the extra energy is required for the reactant molecule to give the product. So this extra energy is known as what? Activation energy. So now here threshold energy we can write as the average kinetic energy of reactant plus activation energy. So average kinetic energy plus activation energy. Activation energy. Okay, simply you can remember in this form. Okay, so what is the threshold energy is equal to average kinetic energy. This is the average kinetic energy, and activation energy, this much is what? Activation energy. So sometime it is also called EAF. What is the meaning of EAF? Activation energy of forward reaction. Okay, here reactant is converting into product means that is known as what? Forward reaction. Okay, so now here this is known as, this is also very important, this is the delta H. Delta H means this much is known as what? Delta H. What is the delta H here? Enthalpy change, change in enthalpy. Okay, so based on this delta H value we can decide whether the reaction is exothermic or endothermic. Okay, so if delta H is negative, so here what is the delta H formula? Delta H formula is enthalpy of products minus enthalpy of reactants. Okay, so what is the delta H here? Enthalpy of reaction. So enthalpy of reaction formula, enthalpy of product minus enthalpy of reactant. Okay, so this is the enthalpy here. Enthalpy is nothing but average kinetic energy, how much energy it is having, and this is the energy of the reactant. So when you observe here, reactant is having more energy, product is having what? Less energy. So less minus more means again you will get what? Delta H is negative. So in this particular reaction, what I have represented here you will get delta H is negative. So in this case, this forward reaction is what? Exothermic reaction. Okay. So now let us take one more graph like this. Okay. Okay. So now here I am going to take the reactant. So we know this is what children? Average kinetic energy. Average kinetic energy of what? Reactant. Okay. So now this reactant is going to give us a product. So now this is known as what children? What is this? Threshold energy. This is what? Threshold energy, and okay, this is known as what? Activation energy of forward reaction. Okay. So now what is this now? What is this part? This is the average kinetic energy of product. Average kinetic energy of product. Okay. So now this is known as what? EAB. Activation energy of backward reaction. What is EAB children here? Activation energy of backward reaction. Okay. So now in this, what is delta H for forward reaction? Delta H is equal to enthalpy of product minus enthalpy of reactant. Enthalpy of product minus enthalpy of reactant. Okay. So now in this particular diagram, when you observe carefully, the reactant is having less energy, product is having what? More energy. So more minus less, obviously you will get positive. Obviously you will get positive. So now in this particular representation, forward reaction is what? Endothermic reaction. It is going to absorb some energy. Okay. So this is about the transition state theory. So here what are the main important points in the transition state theory means children? They will ask you enthalpy of the forward reaction, enthalpy of backward reaction. Okay. So you just learn the enthalpy of forward reaction. Delta H is equal to enthalpy of product minus enthalpy of reactant. So enthalpy of backward reaction means automatically it will become reverse. Okay. So this is about the transition state theory and collision theory. Okay. So now what we have learned in this class? What we have learned in this class? Let us recall quickly. Okay. Let us recall it quickly. What we have learned in this class. Okay. Right. So we have learned about the theories. About the theories we have learnt. So what are the theories explains the rate of reaction, means how the chemical reaction is going to take place. Okay, theories explains the rate of reaction. There are two theories are there which explains the rate of reaction. The first one is collision theory, second one is the transition state theory. What is collision theory? What are the main postulates of collision theory? We know that is collision theory, any chemical reaction takes place due to what, children? Collision of the reactant molecules. And here every collision is not give product, only some collisions only will give the product. They are known as effective collisions. So the effective collisions are indicated with the F, fraction of effective collisions indicated with the F. And here number of collisions per second is known as what? Collision frequency, Z, right. Next, so a collision want to be an effective collision, it must cross two barriers. One is the energy barrier, another one is the orientation barrier. So energy barrier, this is the energy barrier. So the minimum energy, so here also you can write as the threshold energy. So this much energy a reactant molecule must cross to give the product. And not only it should cross the energy, but also it cross the orientation also. When it cross orientation also, it will give the an effective collision. So this is the proper orientation, this is the improper orientation. Orientation barrier we indicated with the P. Okay, right. Okay, so now here rate is directly proportional to concentration to the power n. We know from the rate law, rate expression, rate is equal to K into concentration to the power n. So here you take this value constant. So now rate is directly proportional to K, 1. And here F is directly proportional to rate. So here what is the F? We know F is nothing but fraction of effective collisions. Fraction of effective collisions are directly proportional to the rate. And fraction of effective collisions are related with the Boltzmann constant, Boltzmann factor, that is minus EA by RT, where EA is the activation energy, R is the ideal gas constant, T is the temperature. Okay. So from 1 to 3 equations we can write as K is directly proportional to F, or K is equal to e to the power of minus EA by RT. So here K is equal to A into e to the power of minus EA by RT. So this equation we can write as K is equal to P into Z into F, like that also we can write. So here F is equal to what? F is directly proportional to minus EA by RT. Okay, and where P is the orientation barrier, Z is the collision frequency. Okay, this is very important bit, sometime they will give. Okay, so here next we are going to take the modified form of Arrhenius equation. So here what is the modified form of Arrhenius equation? Just we are applying the log values. So when you apply the natural log, ln k is equal to ln a, so this exponent will become plus minus EA by RT. Okay, so now then after we are going to take this natural log base 10 values we are going to take. We know very well how to convert this. Later on I explained you about the graphs related to that equation, y is equal to minus mx plus c. Sometime directly they will ask in the JEE Mains, what is the correct graph which represent the Arrhenius equation. Okay, these are the graphs, slope values also you remember. Okay, next, limitations of collision theory, where it is applicable, why, what are the limitations of this collision theory, and thereafter transition state theory. What is the transition state theory and the important terminology I explained in the transition state theory. Okay, right children. So with this I am going to end this video. So I hope you like this video. So thank you for watching. అది ఆఫ్ చేశారు అది